Hello, in today's lesson, we want to talk about identity element, which is a concept under binary operations. Alright, let's start with this scenario. Let's assume that we have a given set, that is the set of real numbers, and that is the mother set of all numbers. So let's assume that we are having, that is the mother set of all numbers. And let's consider these four basic operations in math. Let's say the addition, multiplication, we have subtraction, and then division. Okay. Now I'm picking one of the elements in the set of my choice. So let's say I'm picking the number 2. Again, the operation that I'm having there, I want to use the addition operation. Okay. Now my question is 2 plus what number in the set given will give me the same element, that is 2. Can you guess that? Good, you are correct. You are going to get 0, that is 2 plus 0 is going to give us 2. Again, what element in the set given plus 2 will once again give me the same element, that is 2. Indeed, you are correct. You are going to get the same element, that is 0. You realize that 2 plus 0 is equal to 2. And again, 0 plus 2 is equal to 2. This element, which is 2, was in the set given. I combine this element 2 with another element and an operation, and the result is the same 2. Let's consider another scenario. Let's say I have the number, I'm picking the number 3. I'm using the operation, that is this operation, that is the multiplication operation. 3 times what number will give me 3? Can you guess that? You are correct. It's going to be 1. 3 times 1 is going to give me 3. With the same scenario, what number or what element times 3 is going to give me the same 3? It's going to be the same element, that is 1. Now you realize that there is a number or there's an element, when combined that with an operation, it gives you the same element. In this case, for the first scenario, we realize that 2 plus 0 gave us 2. This 2 plus an element gave us the same original element or the first element, that is 2. For the second scenario, we also realize that 3 times a certain element gives us 3. Now, a situation whereby an element from the set operates on a different element and the result remain unchanged, then that element that is causing that is known as the identity element. In this case, the 0 that we are having here is known as what we call the identity element. When it comes to the multiplication on this side, 3 times 1 gave us 3. So the element 1 that is there is referred to as the same identity element. That is the basic idea about identity element. It is an element in a set in which when you use that and then you combine that element under an operation, the result remain unchanged. So we are saying that an identity element or a neutral element of a binary operation operating on a set is an element of the set which lives unchanged every element of the set when operation is applied. That is the basic reason, or that's the basic meaning of the identity element. If you pick any element in the set given, this set, if you pick any element in a set given, and then you combine that with an operation, the end result is going to remain unchanged. So we are saying that mathematically, then if there exists an element A, which is a member of the real number set such that A, that is an element, operating on E, that is identity element, which is equal to the same E operating on A, and the result is equal to A for all A belonging to R, then A is called the identity element or a neutral element in R under the operation. So all that we are saying is, yes, we have several operations, but the basic definition is a number A operating on the identity element, that is E, supposed to give you the same element, that is A. And again, E operating on A should give you the same element, that is A. The A that is there is referring to our identity element. That is a symbol that we use to denote the identity element. Now, one basic condition I should know about the identity element is always the operation there is supposed to be commutative. That is one basic condition about the operation that they want to use to find your identity element. The operation is supposed to be commutative. That is why the definition is saying that A triangle E, that is A operating on E, is equal to the same E operating on A, and this is supposed to give you A. So the operation in question is supposed to be commutative. All right. Although there are other instances whereby the operation is not commutative, but we try solving for identity element and you get a value for that. We'll get to that point. We'll go through some examples like that. Okay. But without wasting much time, let's consider an example. Okay. So we have an example here. It says a binary operation, that is the star operation, is defined on a set R of real numbers by x operating on y is equal to x plus y plus 6. The question says find the identity element. In this case, the operation that we are having there is the star operation. Okay. And the definition has been given for the operation. That is, the first number operating on the second number is equal to the first number or the first variable plus the second variable plus 6. Now, in this question, what we are going to do is, first thing, let a variable of your choice denote the identity element. Okay. So let's say E represents the identity element. Okay. So now that we are having our E to represent the identity element, the next thing you are going to do is you are going to write the basic condition for the identity element, and that is you are going to have our X operating on the identity element. This is supposed to be the same as the identity element operating on X, and this should give us X. This is the basic condition that you have to write. After writing this basic definition or condition, what we are going to do next is we are going to pick one. So X operating on E is equal to X. This is what I want to use. I'm picking this side. Okay, so this is equal to this, and that is what I'm having here. And then you try using the definition that has been given in the question, that is the star operation there, and then you try expanding this and then solving for your E or make it E the subject. Okay, so per the definition, we are saying that X, that is the first variable operating on the second variable, is equal to the first variable plus the second variable plus 6. In this case, our X is the first variable, our E is the second variable. So we are going to have our X plus E plus 6, and this is equal to our X. With this, we try solving for our E. Okay, that is making sure that E stands on one side of the equal to sign. So we are going to have our E being equal to, we have our X minus 6. All right, X minus X is going to give us 0. So we are going to get our E to be equal to negative 6, which implies that therefore the identity element is negative 6. Let's try our second example. It says the operation, that is the triangle operation, is defined over the set of random numbers a operating on b to be equal to a plus b minus 3ab for all a comma b belonging to R. Find the neutral element, which is the same as we finding the identity element. Okay, now the question wants us to find identity element. So the first thing, what is your identity element? Use a variable of your choice to represent the identity element. Okay, so in this case, I want to use a different variable to represent the identity element. So let p represent the identity element. You can use the e, you can use any variable of your choice to represent the identity element. Okay, so my p is the identity element. After representing your identity element by a variable of your choice, write the basic condition for the identity element. Okay, in that case, we are having a and then b. The a is the first variable, b the second variable. You can use one of them of your choice. So we are going to have a operating on the identity element. So what is your identity element? P. So a operating on p. This will be equal to interchange the position of the a and p. This will be equal to the p operating on a. This is the commutative property. All right. So this will be equal to the same a. So this becomes the basic condition for the identity element. When you are done, pick one side of the equation. That is, either you pick this side, or you pick this side. Okay. So now we are going to have our a operating on p is equal to a. All right. So now let's consider this side and then expand that. We are going to use the definition given. In this case, our first variable is a, our second variable is p. So the first variable operating on the second variable is equal to the first plus the second variable minus 3 times the product of the first and then the second variable. So we are going to have our a plus p minus 3 times ap, and this will be equal to a. So from this particular equation that we are having here, we are going to solve for p. Let's group like terms. We are going to maintain a p minus 3 ap, and this will be equal to a minus a. Okay, there's a common factor that is p. In fact, that is the identity element. That is what we want. So we have to factorize it out, and that is going to give us p bracket open. We have 1 minus 3a, and this will be equal to 0 because a minus a is 0. We are solving for p, so we are going to divide this side by the 1 minus 3a. We divide this side by the 1 minus the 3a. Okay, we are going to cancel out, and then 0 over any expression is 0. Okay, so in this case, we are going to get our p to be equal to 0. And our p, which is the identity element, is now equal to 0. Therefore, per conclusion, the identity element is 0. So that is how we can use this concept of identity element to solve some questions. Don't forget our next video. Our next video, we are going to solve more questions on identity elements, because I told you from my previous statement that there are some operations that are not commutative, but when it's solved for the identity element, it's possible you get a number for that. All right, so we end today's lesson here. Watch out for that video in the identity element part 2. Thanks for your time.